Hey guys, Mrs. Traber here. Today we're going to look at parallel and perpendicular lines. Our learning target is to connect a bunch of things we've been doing. We're going to look at images and how they're equidistant from their line of symmetry and how they're perpendicular to the connecting line, as well as look at the relationship with perpendicular and parallel slopes. You'll know you're successful when you can reflect points across a line. We're going to look at our homework from yesterday and see what questions you might have, then take notes on results of transformations in parallel and perpendicular lines, as well as do some homework out of the book. It says what you'll need for the day, but I think you'll be able to be okay using Desmos instead of graph paper. Let's jump in. Here are the answers to yesterday's assignment. Pause the screen now and compare these to yours, and if you have any questions, come see me on Zoom. Remember that you should be submitting this on a form every day with a picture of your work, otherwise you're not going to get full points when I go to grade that. Let's get started though. This one says we're going to, wait, I went 2 slides too far. Oh, there we go. This one says, begin by graphing the equation y equals 3/5 x minus 4. Let's pause there. Let's do that before we read anything else. Graphing this equation. Okay, so we've got a review a little bit that we're going to pause and think about on how to graph a line. It's got a slope-intercept, it's a slope-intercept form, so let's use the slope and the intercept to graph, starting with -4. Remember we've got y equals mx plus b. We're going to start with graphing b, which is our y-intercept. So this is just a review on the side before we even get to the geometry life that we're trying to lead. So graphing B, it's at -4. So I'm going to go down here, 1, 2, 3, 4, and there's my first point. And then I'm going to use slope to do rise over run and get the rest of my points. In this case, it's 3/5. So I'm going to rise 3 and run 5. So up and over. So rise 3, run 5. Here's my next point. I can do it again, rise 3, run 5. I can go backwards, drop 3, run 5, and drop 3, run 5 again. So here's a really good line for ourselves, and I'm going to try to connect it nice and pretty. Lines have arrows on either side because they go on forever, and now I'm good. Okay, back to our instructions. Begin by graphing the equation y equals 3/5 x minus 4. Done. Use tracing paper. We're not doing that because we're online students, to translate the graph up 5 units, up 5. So translate, remember, is moving left, right, or up, down, and it told us go up 5. Write the equation of the resulting image. Okay, so I'm going to change colors here, and we'll make our image be red. So it said go up 5. So when we take any of the points, I'm going to use the y-intercept. I'm going to go up 5, 1, 2, 3, 4, 5. Here's a new point. Let's do this point, up 5, 1, 2, 3, 4, 5. I'll do it again, 1, 2, 3, 4, 5. I'll do some of these ones, 1, 2, 3, 4, 5. And then I'll do this one, 1, 2, 3, 4, 5. Okay, so here is my image after it went up 5 units. Okay, what is the relationship between these? It said write the equation. Let's do that. I know it's going to be in y equals mx plus b form. Let's check the slope and the intercept and see what they are. So the slope, I can think about a slope triangle here. And if I count this out for the red line, it went up 1, 2, 3, and it went over 1, 2, 3, 4, 5. So it actually also has a slope of 3/5. And then my b is where it crosses the y-intercept. So here's the y-axis, and it crosses right here at b equals 1. So I'll say plus 1. So let's compare these two. I have y equals 3/5 x plus 1, and my blue one was y equals 3/5 x minus 4. What do you see here in comparison between the two? What relationship do they have? How do their slopes compare? Their slopes are the same. So slopes are the same, or we could say equal. And then let's look at the picture. What type of lines are these? These are parallel lines. All right, so there's our first idea about parallel. 2 things happening here. Parallel lines never cross, and they have the same slope. Let's look at our other type of lines. This one says we're going to graph a line, which is the same one as before, so it's already graphed for us. We've done this. Y equals 3/5 x minus 4. This time it says rotate it clockwise about the point 0, 0, and write an equation for the result. This is where the patty paper would have come into play and the graph paper, but we're going to do something different because we're online students. We're going to use our technology. I'm going to end the slideshow, and I'm going to kind of mess with it as an image here. So I know you see like the rest of the slideshow in the background with my editing access, but let's actually take this image, and there's a rotate tool right here. And when I highlight and move it, I can rotate it. So let's actually do this, and it kind of snaps into place right there if I go to the top. So it wants me to go 90 degrees clockwise. Clocks go this way. So I'm going to go 90 degrees, that's one turn. And it snapped right there. Okay, let's look at what we have. The numbers are weird, right? Now the y-axis is over here and the x-axis is over here, but if I thought about it, just the line moving, the axes would stay the same. So this new line, let's see if we can figure out its equation. And let me move my screen to full. There we go. So let's see if we can figure out this guy's equation, assuming that our x and y-axis were switched. So these are really positive, and these ones are negative, and there we go, that looks good. Okay, so let's see if we can figure this guy out. First, let's figure out where it's crossing the y-axis and our slope. So let me find some points. This is a good point to use, and here's another good point to use. I'm noticing ones that go right on the crosshairs, so let's count out our slope triangle. This one rose 1, 2, 3, 4, 5. And it ran 1, 2, 3 backwards, so it went -3. Okay, so my slope was rise 5, run 3, and it was negative. So I'll throw a negative on there. Doesn't matter if it's on top or bottom. Our B is where it went through the y-axis, and that's right here, 6, 7. It's like 6.7 or something. Approximately -6.75, we'll call it. All right, it's actually 6.6 repeating, but beside the point. Okay, so let's make this be a line. We've got y equals -5/3 x minus 6.75. And our original one, remember, was y equals 3/5 x minus 4. Okay, now same idea. We wrote the equation, we're good. Describe the relationship, and let's look at slopes again. So relationship on our picture, we need to actually graph both of them at the same time. Let's utilize decimals for that. So let me see if I can pull that up. Here it is. Let's graph both of them. Y equals 3/5 x minus 4. And our other one was y equals -5/3 x minus 6.75. Okay, let me make this a little bit more bold. Let's take a look at it. What is the relationship between these two lines? Doesn't it look like a right angle? Which makes sense, because remember, we rotated this 90 degrees, and 90 degrees are right angles. So that's our picture in our head, is we made perpendicular lines. Now let's go back and look at the slope that we had, which had erased my work, gosh darn it. But our slopes were, grab my pen again, 3/5 and -5/3. So this made perpendicular lines, and our slopes got flipped and negative. All right, let's take some notes on what we've discovered here. So two different things going on with parallel and perpendicular lines. Parallel lines, so these ones are parallel. They will never cross, they do not meet, and their slopes are the same. All right, and a good way to remember this is parallel lines have two parallel lines within the name of it. The L's are parallel, so that's how I remember which one's which. This one, whoop, too far. This one, oh my goodness, pen back please, are perpendicular. And they come to a right angle. And what else? Their slopes are flipped and negative. What we say is negative reciprocal. So for example, we had 3/5. It got flipped to -5/3. Or another example could be 1/2 gets flipped to be 2/1, and it's negative, which is actually just -2. Last example, say I had a slope of 5, which really could be written as 5/1. It would flip to be 1/5 and become negative. So there's 3 examples of how slopes will work for you. What's last for us today is to look at our homework assignment. So let me pull that up for you. We're looking at 1, 2, 3. Let me get there. 1, 2, 3. And down to review preview. Here it is. The first one, number 76, are some probability problems I'd like you to try. Number 77, it's asking you to do what we had done last, where you find the equation of a line that goes through a point and is perpendicular. I advise you to use the decimals E tool for this one. So when you click on that E tool, it opens up and it's got some stuff done for you already. It's got a line graphed and it gives you a point, and you're able to move some stuff around and then actually write your equation in there. So for this, it gives a hint within decimals that might be helpful to you. Read the instructions and try that out with the E tool if you don't have graph paper. For number 78, it's talking about angles and naming them. Try out that and use the homework help link if you're not sure. Number 79 is solving equations, and then 80, you're filling in a table, and again, there's the E tool. Check that out. Those are super helpful. If you have any questions, come see me on Zoom. Otherwise, we are all set for today, and I will see you tomorrow. Bye.